Good morning!
What's up, Carlo?
Today's video is an introduction to quadratic functions. What are they? What do they look like?
How do they work?
I will tell you.
I'm going to start by going over the other types of functions that we've spent some time talking about. Here's one. It's a linear function. A linear function is defined as having a constant rate of change, and when you graph it, it looks like a straight line. You can kind of see that in the name, line, linear. Here's an example. Last unit, we focused on exponential functions, which look like this. If you'll recall, an exponential function is one that has a changing rate of change. As the x values increase here, the y values increase exponentially. And here you'll see an example of a quadratic function. A quadratic function comes from an equation that has an x squared in it, and when you graph it, looks like what you see here. So when it's on a graph, it looks kind of like the letter U, and this shape is called a parabola. Quick way to remember that, the word quadratic has a letter U in it. Linear and exponential do not. So quadratic function, U in the word, U on the graph. Now let's talk about some key features of quadratic functions. Okay, so there are more to quadratics than just being U-shaped. When graphed, all quadratic functions are symmetrical and have something called a vertex. So in order for something to be symmetrical, that means that there exists some line that you can fold the thing over and have it match up perfectly. That line is called the axis of symmetry. So in this example, the axis of symmetry, the line that I would need to fold over to make the two halves match up, is just the y-axis. And the equation for that line is x equals 0. That's this line right here. Let's say we have a quadratic that's shifted over to the right a little bit. Same idea, I look for the line that splits it directly in half. In this case, that line would be x equals 2. So this quadratic function has an axis of symmetry of x equals 2. Just so you can see that idea a little more clearly, here is that axis of symmetry in red. This red dotted line is the line x equals 2, and you'll see that if I were to fold this quadratic function over that line, the two sides would match up perfectly. Okay, now let's talk about the vertex. So every quadratic function has one vertex, and that vertex is going to be either the maximum or the minimum point of the function. And the way that you can tell whether the vertex is a maximum or a minimum is based on the direction that the quadratic is facing. Let's start with this example where we have a quadratic function that is facing up. You see these two arrows are both pointing up. That means that the y values of this quadratic function are going to increase to infinity. What that means is that this vertex point is the minimum value of the function. So this point right here is the lowest possible value for that function. So we identify the point of the vertex just like we identify like any other point on a coordinate plane. I can see the x value is 2, the y value is 0. So the vertex is, let's use blue, that's 2, 0, that point right there. And that is a minimum because it's the lowest value that quadratic function has. Now if we have a quadratic that's facing down, now that's a different story. So these arrows are both pointing down. That means that this quadratic function has all y values down to negative infinity. So in this case, we identify the point of the vertex. It's right there. That's 0, 0, the origin. And that vertex is a maximum because this point right here, that's the highest possible value on that quadratic function. Every other value is less than that one. So the vertex represents a maximum.